Welcome to this video on how to order decimals. Let's get started with just a review of how we read a decimal number in maybe a different way than you're used to. We would probably all call this 10.8, but there's another way to describe this. We describe it first as the whole number part, and then we describe the decimal part a little differently. We describe it based on how many places it goes out and the decimal values that are there. In this case, we go out to the 10th place, and there's an 8 in the 10th place. So we can describe that as 10 and 8/10. Here we have another example, 0.85. Here we have no whole number part, so we might say 0. And because we want to look at this as one number, 85, and then consider how many places it goes out to. It goes out to the 100th place, 85 hundredths. Last example, 17.279. As you might have expected, now we go out to the third decimal place. That's called the thousandth place. So hopefully you're following the pattern here, 17 whole units and 279 thousandths. The reason I went through that is that it is related to the way that we sequence decimal values. So let's take a look at actually sequencing some values. Here we have 4 decimals, and we can see that the whole number part is the same, but the decimal values are all different. We have 4 here, 3 here, 2, only 1 in this number. What I recommend in this case is to add zeros so that they all have the same number of values after the decimal point. So I put a line here that indicates we are going to go out to 4 in each case. I add 2 to the first number, 1 to the second number. We don't have to add any to the third number. And we add 3 to the fourth number. Now they look more consistent, and it makes it easier to compare them. So we could think of this as 108,700, 108,450, 108,799, and 108,000 even. This makes them easier to compare. Now let's order them from greatest to smallest. We look over those numbers and we look for the biggest one. And it looks to me like 108,799 is the biggest of those. You could also, because all of the whole numbers are the same, we could ignore the green part and just compare the black numbers. That will work as well. So 8,799, biggest number. We keep going. What's our next biggest number? It looks like 108,700 is the next one. Then 108,450. And then finally, 108,000 would be the smallest number. Hopefully that makes sense to you. It might take a little bit of practice to get used to adding these zeros, but I think it's an effective way of making it much easier to compare and get them in the right sequence. All right, we're going to look through 3 example problems here. This first one is pretty basic. 2 machine shafts are measured. Part A measures 1.513, and part B measures 1.52. So I'm going to write these 2 numbers down. 1.52. And I'm going to do the thing that we just talked about, which is to add zeros so that they line up, so that they all have the same number of values after the decimal point. Since part A had 3, I gave part B 3. Now we are comparing. We could think of it this way, 1,513 with 1,520. And it becomes very clear that 1520 is larger than 1513. So this is our answer. That is the larger part. Same technique, but just doing it to compare two numbers. Now here's an example where we need to compare four numbers. Four runners ran a 100-meter race. Which order did they finish based on the chart below? And we're listing the order from first to last. Look over your list. We see that there's 3 values to the right of the decimal here. So let's give them all 3 values. And I think you can see how that immediately starts to make this easier to compare. Since these first whole numbers, that's really the first place that you want to compare, they're all the same. So that doesn't really help us out. So if it simplifies things for you, you can really focus on the numbers after the decimal if the whole numbers are all the same. So I'm just comparing these numbers. And we are looking for, because in a race, the shortest time or the smallest number is the one that we're looking for. We are looking for the smallest number here. That would be Sam is number 1. The next smallest number would be 450. Tori would be number 2. The next smallest number is 500, 3. And then finally, Kelly finished 4th. Okay, one more example for you. This is kind of a classic problem. Which of the following jars of sauce is the best deal? Hint, you need to calculate the cost per ounce for each and then find the lowest number. So this can feel a little bit tedious because what we need to do is division 4 times. We need to divide $2.15 by 11 ounces because that's how we calculate the dollars per ounce. And then we need to do it for all of these others, $2.65 divided by 15. So this is just setting up what are we going to have to do in order to answer this question. We haven't done the work yet, but I encourage you to go through these calculations with me because it gives you some practice getting numbers out of your calculator and then writing them down to what I would say is a reasonable number of decimal points for comparison. I would say 4 decimal points is usually going to be plenty. So we do this division, and you should get something like 0.1955 for A, for sauce A. For sauce B, 0.1767. For sauce C, I get 0.2093. And for the last one, I get 0.2125. Now I'm just cutting off the values so that we have 4 digits after the decimal point. That makes it easier to compare. Now, usually it's going to be pretty obvious at this point, which is the lowest, and that is the case with this one. Clearly, 1767 is lower than 1955, 2093, and 2125. We don't need to organize these from smallest to largest. We are just looking for the best price. There it is, sauce B. All right, that wraps up this video. Now it's time for you to do some practice on your own.